Alright, today is going to be a review for the first quiz of the chapter. We're going to start with just some simple rewriting. So we have radical form. We want to take it from radical form and write it into rational exponent notation. So that just means write it as a fractional exponent. We have the fifth root of 3, which means that exponent there is 1. So this is 3 to the 1/5 power. Now that 2 can also be on the outside or on the inside. So this would be 4 to the 2/3 power, but you always want to make sure that your base is rewritten in simplest form. 4 can be rewritten as 2 squared, so it's really 2 squared raised to the 2/3. We have a power to a power, so we're going to multiply, so that's actually 2 to the 4/3 power. And our last one here, we have x to the 7/3. Don't forget, whatever is attached to that x is going to stay as the numerator, the root is the denominator. So now we're going to go from rational exponent into radical form. So 3 to the 1/3, the denominator is the root, so that's the cube root of 3. And we've got, for number 2, a -8 to the 2/3 power. You want to be careful here. Remember, the numerator, that means that we are squaring that -8. Anytime it's raised to the even power, we've got 2 negatives, so that's going to mean it's going to be a positive answer. We're going to rewrite that. I'm going to get rid of the negative since I know it's going to be positive, so it's 2 to the 3rd raised to the 2/3. 3 times 2/3 is going to give us 2, so 2 squared is equal to 4, so we don't even actually have to write it as a radical at all. And last, we've got number 3, x to the 5/4. So that's the 4th root of x to the 5th. We need 4 to go to the outside, and we have 5. That means we can take an x out. We took 4 of those out, which means we have 1 left over on the inside. So that's x times the 4th root of x. Don't forget, anytime you're writing a radical, you do have to write what root you are taking. So we're taking the 4th root. Make sure that you don't forget to write that little 4 there. Alright, so let's move on to simplifying. We want to perform the indicated operation. Our first problem here, we just want to simplify our piece, so we first look at the coefficients, a -4/20. That's going to give us a -5 on the bottom, and it doesn't matter if the negative is on the top or bottom. You can put the negative on the top, or you can put the negative with the 5. We look at our a's. We've got an a to the negative first on the bottom. A negative exponent means that we're going to do the reciprocal. We're going to move it to the bottom. We already have 3 down there. We're bringing 1 more, which means we now have 4 a's on the bottom. Our b's, we've got the -5 on the bottom, so we got to take the reciprocal, move it to the top. We have 9 there. We're bringing 5 more, which means we now have 14. And last, we've got c to the -4th. We want to bring that to the top to get rid of the negative. We already have that 1. Don't forget that is representing 1, so 1 plus 4 is going to give us c to the 5th power. In order for your answer to be in simplest form, you have to have positive exponents, and you can only have your variable in one spot. But this -5, that's not an exponent, so that's okay. That's just a negative coefficient. We move on to number 2. We are multiplying like bases. If we multiply like bases, that means we're going to add exponents, whether those exponents are numbers or variables. Since we are adding variables here, we're going to add like terms. 3a and 10a is going to give us 13a plus that 1. We move on to the y's. We're multiplying those like bases, so again, we're going to add those exponents. 5c and 3c is 8c plus 2. We can't combine those two pieces because they're not the same variable. So that would be our answer in simplest form. For number 3, we are dividing like bases, and since we divide, we subtract. So we've got 5a plus 9. Don't forget you're subtracting that whole quantity, a minus 4. For our y's, we've got that 3c plus 7, subtracting the entire quantity, 2c plus 4. You just want to make sure that you're distributing that negative. So 5 minus a gives us 4a. 9 minus the -4 means we're really adding 4. So that's plus 13. And then we've got 3c minus 2c, which leaves us with 1c. 7 minus 4 leaves us with a positive 3. For number 4, You want to be careful. We've got 4 times this quantity. We have a power raised to a power here. The 4 is not being raised to the 2/5 power, so that 4 is still going to stay on the outside. We have a power raised to a power, so that is going to be multiplication. We're going to multiply 1/2 times 2/5, and that gives us 2/10, and 2/10 is going to reduce down to 1/5. Again, we want to be very careful here. The 1/5 is only attached to the x because the 4 is not in parentheses. So the 4 does not go inside of the radical with the x. This is the 5th root of x. So be very careful what goes inside the radical and what goes outside the radical. Number 5, we are multiplying. We are multiplying a 4 times a 2, that's a coefficient, so you're going to do those like normal. 4 times 2 is 8. We are multiplying like bases of x's, which means we are going to add the exponents. 1/2 times, or plus 2/5 is going to give us 9/10. And the 8 is not inside the radical because 9/10 is only corresponding to the x because there's no parentheses. That means we've got the 10th root of x to the 9th. We need 10, we only have 9, so nothing can be moved to the outside. Number 6, we have this whole quantity raised to the 1/4. I'm going to distribute that to the top and the bottom of the fraction, so that's x to the 1/4 all over 16 to the 1/4. So on top, there's nothing really that can be broken down. That is just going to be the 4th root of x. And then on the bottom, we've got 16. We always look to see if we can break our bases down. You may have memorized what this is by now. If not, we have 4 and 4, 2 and 2, 2 and 2. So 16 can be rewritten as 2 to the 4th power, all raised to the 1/4. So now we've got a power to a power, which means we're going to multiply. 1/4 times 4 is just going to be 1. So that's 2 to the 1st power, which leaves us with our answer of the 4th root of x all over 2. Number 7, we've got these two pieces, these two radicals that are being multiplied. The first thing that I notice is they're both to the 4th root. So I can go ahead and put them underneath one radical. 3 times 27 is 81. X squared times x to the 3rd. I'm multiplying like bases, which means I'm going to add the exponents to get x to the 5th. We look at 81. 81 is 9 and 9. Each 9 breaks down to 3 and 3. So this can be rewritten as 3 to the 4th power. We look to the radical to see how many we need in order to move it to the outside. We need 4. We have exactly 4 3's, which means all of our 3's go to the outside. We've got one group of 3 4's. Sorry, we have one group of 4 3's. Moving to the outside, we've got 5 x's, which means we can move one of them out to the outside, and we have 1 left over on the inside. Number 8, we've got the 5th root of 2, the cube root of 8. They don't have the same radical, they don't have the same base. So it looks like I can't really do much, so what I'm going to do is I'm going to change it into fractional exponents and see if that helps. That's 2 to the 1/5, and that's 8 to the 1/3. We look at 8. 8 is a base that can be broken down. We know that 8 is really 2 to the 3rd power. So that's 2 to the 3rd times 1/3, because we've got a power to a power. 2 to the 1/5 times 2. This is still going to be inside of the radical because you still have a fractional exponent, but 2 has become a whole number. There is no radical left, so that 2 stays on the outside, and this is the 5th root of 2. Don't forget, our answers always have to be in simplified radical form. We never want fractional exponents in our answers. Number 9, we see that we have the cube root on top and bottom. So I'm going to see if I can reduce something. Sometimes we can, sometimes we can't, but I always try first. We are dividing like bases, which means we subtract using our who wins rule. The bottom's going to win because it's bigger, which means we've got 1 left on top. 27, 10 minus 5 is going to leave us with 5 on the bottom. Now I'm going to go ahead and break this back apart. The cube root of 1 just means that we have 1 on top. 27 can be rewritten as 3 to the third. We need 3 to go to the outside, so I have exactly 3. So 3 goes to the outside, no numbers left on the inside. We have 5 x's, we need 3 of them. So I can bring one group of x's to the outside. 5 minus 3 means we have 2 x's left over on the inside. We cannot have any radicals on the bottom of our fraction, so we have to rationalize. We need 3, we only have 2, which means we need one more to get rid of that radical. So now on top, we've got the cube root of x. On the bottom, we had a 3x out there already. We are bringing an additional x out. So x times x is going to leave us with 3x squared on the bottom. Be careful. Just remember that you created this perfect cube root, moving one more x to the outside. So you've got to make sure that you're bringing that extra x out and doing the x times x to get x squared. All right, go ahead and turn on over to the back side. For number 10, we have 1x raised to the 2/3, raised to the 1/4, raised to the second power. This is a power to a power to a power, and we know a power to a power means multiplication. So we multiply 2/3 times 1/4 times 2, and that ends up being x to the 1/3 power. And then we've got to change that from fractional exponents to radical form, the cube root of x, and we're done. We need 3, we only have 1, so we can't move anything to the outside. For number 11, we've got the 4th root of 1/8. Nothing I can really see there going on, so I'm going to break it into 2 pieces. The 4th root of 1 and the 4th root of 8. Well, we know the 4th root, or any root of 1, is just going to be 1. I can rewrite 8 as 2 to the third. I need 4. I have 3, which means I need to multiply by 1 more 2 to, in this case, get that perfect 4th root. So on top, I now have the 4th root of 2. On the bottom, we've created that perfect 4th root, so there's no radical left, and we've moved a 2 to the outside. For number 12, and this is a really good question to pay attention to. We are multiplying pieces. We don't have the same base. We don't have the same exponents, but if I look at 4, 8, and 2, although they're not the same base right now, I can make them into the same base. 4 can be rewritten as 2 squared. 8 can be rewritten as 2 to the third. And on the bottom, 2 to the 1/2. So when I multiply a power to a power, I get 2 to the 4/3 times 2 to the 3/4, all over 2 to the 1/2. Now that all 3 pieces have the same exponent, I can combine them together. I'm multiplying like bases, which means I'm going to add those exponents together. 4/3 and 3/4 is going to give us 25/12. And on the bottom, 2 to the 1/2. Remember, when you're combining like bases, you're not changing the base. So that 2 times 2 is not going to become a base of 4. It's still a base of 2. When we divide, we subtract those exponents, and we end up with 2 to the 19/12. It's the who wins, and the top is bigger than the bottom. So we subtract 25/12 minus 1/2, and we're left with 19/12. We change this into radical notation, so that's the 12th root of x to the 19th. We need 12, we have 19, which means we can bring a 2. Well, where did that x come from? We can bring one of those 2's to the outside. And we took out 12, which means we have 7 left over on the inside. 2 to the 7th power, we go ahead and multiply that out, and we get 128. Alright, the next couple problems are really to concentrate on paying attention to whether an answer should be positive or negative, or what piece is being raised to the exponent. At number 13, we have parentheses, a -9 raised to the 2/3 power. If I were to change this into radical notation, that would be the 3rd root, the cube root of a -9 squared. Remember, the numerator is the power, and the denominator is the root. Because I'm squaring a negative, That means we're going to have two negatives, which makes it a positive, so this is the cube root of a positive 81. We can rewrite 81 as 3 to the 4th power. We need 3, we have 4. We can bring one of those 3's to the outside, and that leaves 1 left over on the inside. Again, don't forget, we've got lots of 3's in this problem. Don't forget to write that superscript of 3 right there, indicating the cube root. When you look at number 14, there's one subtle difference. We don't have parentheses, which means here we had a negative 9 raised to that quantity. Since that negative is not in parentheses, it's a negative, and the 9 is the only piece being raised to the 2nd power. That negative is not included in that radical, so the negative is not being squared. So that negative stays on the outside. Cube root of 9 squared, which gives us that 81 on the inside. We broke it down just like we did last time, so it's going to be a negative 3 times the cube root of 3. So those simple little parentheses is going to make the difference between a positive and a negative answer, which is true as well when you put it into your calculator. So if you forget parentheses in your calculator for number 13, you would end up with a negative answer, even though it's truly a positive. Number 15, we have a negative 64 raised to the 3/4 power. So that means that we're raising the negative to the 3rd power, which means the answer is going to be negative because we're going to have 3 negatives. And we're going to take the 4th root. So we're taking the 4th root of a negative 64 to the 3rd power. Hopefully you are realizing that we have a problem. We can't take the even root of any negative number. You can take the odd root, you can take the 3rd root, or the 5th root, or the 7th root, but you can't take the 2nd, or the 4th, or the 6th. No even roots of negatives, which means this is going to be a no real solution, or no real number. 3 more to go. Number 16, slight change. We now have 64 raised to the negative 2/3 power. Our negative is now located in our exponent, which means we have to take the reciprocal and move it to the bottom. And when we move it, we lose it, and that becomes a positive 2/3. We rewrite 64. 64 is really 2 to the 6th power to the 2/3. We multiply since we have a power raised to a power. 6 times 2 is 12, divided by 3 is 2 to the 4th power. 2 to the 4th is 16, so our answer is 1/16. 17, we want to simplify our radical. We look at 192. I don't have that one memorized. I don't know how that's going to break down, so we use our factor tree. 48 and 4. 4 is 2 and 2. 48 is 4 and 12. 2 and 2. 4 and 3, 2 and 2. Alright, we need groups of 5. We've got 1, 2, 3, 4, 5 2's. So that group of 5 is going to go to the outside. We have a 2 and a 3 left over on the inside. So I'm going to multiply 2 times 3. So I have got the number 6 left over on the inside. We have 15 x's. We need groups of 5. I have exactly 3 groups of 5. So there's nothing left over. We've got y to the 6th. I can bring one group of 5 out to the outside. When I take those 5 away, that means I've got 1y left over. So our answer is 2x to the 3rd y times the 5th root of 6y. I'm going to move that over. There we go. So it looks more like one piece. And our very last one. We are adding radicals together. If we are going to add, we have to have the same radical in order for them to be considered like terms. Right now they're not the same. We break down 16. 16 is really 2 to the 4th power. We have the 4th root. We already have a 4x out there. We're going to bring out that additional 2. X to the 7th, we need groups of 4. We can bring one group out. We don't have any numbers left over, but we have 3 x's left over on the inside. 81 is 3 to the 4th. So we bring that 3 out. We have x to the 11th. We can bring 2 groups of 4 out. That gives us 8. We had 11, which means we're going to have 3 x's left over on the inside. Our first piece, 4x times 2x, is going to give us an 8x squared. fourth root of x cubed plus 3x squared, fourth root of x cubed. We see that after simplifying, we now have, the same radical, which means that they are like terms. So we add the coefficients. 8x squared and 3x squared is going to give us 11x squared, fourth root of x cubed. Alright, don't forget to pay close attention because all of this will be on your quiz.